Okay, I want to do a quick revision or lesson of about series and parallel circuits and to explain to you about current, voltage and resistance. Okay, so maybe you can turn to your booklet and look for this page. Alright, so in electricity we often talk about current, which is I, alright, and then V, which is normally you call it voltage, okay, or you can also call it potential difference, right? And the third one will be R, resistance. Okay, so these are often the common quantities we use in this topic, right? And the most important formula, which I think most of you know, is V equals to IR. Alright, so about current, voltage and resistance. Current is actually quite simple to understand, right? So when current flows, you would think there's the light bulb will light up and so on, right? So that's not a problem. But there's just a few misconceptions I want to clear up. First of all, is that about when the current flows in a circuit. So if let's say I have a circuit like this, right, where I have 3 light bulbs and I have, let's say for the moment, 2 ammeters, right? Current, as you know, will go from the positive to the negative of the battery, right? That's a conventional flow of current. So when the current flows, it flows in this manner. So for many students, they will feel that they think that when this current goes through each light bulb, it gets lesser and lesser. But that is not the case, right? If a series circuit like this, the current, if you say here is 1 ampere, that means to say this ammeter will read 1 ampere, here will read 1 ampere, and when it comes back here, it will be 1 ampere. Current only has one way to flow. It doesn't split anywhere, right? So on the other hand, if let's say you had a circuit that was like this, okay, maybe you recognize this from lower sec days that this is called a parallel circuit, right? How does the current flow? Okay, so if the current comes here, it comes here, it splits into I1 and I2, right? And current is commonsensical. Always tell yourself current is commonsensical, so you can conclude that if this was I, then I1 plus I2 will give you I. Okay, then what is the current here? Okay, once the current goes through these two resistors over here, R1 and say R2, the current will recombine back to I. So it comes back to here to be I, right? So that means to say that the current reading at this point over here, right? And this point over here would be exactly the same. And it only splits up here, alright, when it comes into these two branches over here. Okay, so that was a parallel circuit. Okay, how you know something is a parallel circuit? You look at it, you see that the current splits up. Whereas for a series circuit, the current only has one way to go. It goes this way, and then back. Okay, so it's same throughout the circuit. However, okay, often we will put voltmeters. Okay, what does a voltmeter do? It measures potential difference or measures voltage. Okay, I'll talk more about that later. But so if I put voltmeters at various points here on my circuit, right, I have a V1 over here, and then over here I have V2. How does that affect the current? So you see the current come here, then you might say, hey, does the current split and go towards a voltmeter? Okay, the answer is no. Why not? Okay, two reasons in a sense. A voltmeter is designed to measure voltage, not current. Okay, so it doesn't take any current to it. And the other reason is a very, very, very high resistance. So no current will go there, but everything will go through this light bulb here, and you will just proceed here. It doesn't split again to the voltmeter, but it goes round and back. Okay, so this still remains a series circuit, right? So what I want you to remember, first of all, right, for current, it is logical. You just think logically, sensibly, and you look at it and you see, okay, this current comes here, and then back. Okay, it doesn't go towards any of these voltmeters. So current is what we say, same throughout a series circuit. Okay, so current is same throughout a series circuit. Okay. same throughout a series circuit. Okay, now if you were to look and see in a parallel circuit, just like I said just now, you just see for yourself, current starts from here, comes to here, then what happens? Splits into three parts, right? Splits into three parts, and when it comes back here, it rejoins, it becomes current again, I again. So if let's say here was 1 ampere, here will be 1 ampere. Okay, ask yourself, what do you think if this was I1 here, then I2 here, then I3 here, what is the current over here? Okay, the current over here will be what? If you think carefully, it will be I2 plus I3. Okay, just same likewise over here, you will recombine back I2 plus I3. And then when it comes here, it's basically I1 plus I2 plus I3, which is your total current. So in this case, you can see quite clearly and quite easy to understand that the current splits, right? Again, it doesn't go into the voltmeters over here, okay? They do not draw the current at all, right? Okay, before I talk about voltage and potential difference, maybe I will talk about resistance. Okay, the idea of resistance is simple to understand. So normally in circuits, you have a resistor like this. Okay, so what does it do? Well, as the word resistance means, resist current. So it simply means that if you have a circuit, let's say like this, okay, which has a very high resistance of let's say 100 ohms, how does it affect the current? Well, then the current will be smaller. Whereas if you have a circuit which has a resistor of let's say 10 ohms, then you can say that this circuit will, if the voltage of the batteries are the same, then this current here, I1, okay, would be much larger. So a smaller resistance will result in a larger current flow. Okay, so the idea of resistance is quite, in a sense, also still logical and sensible. Okay, now maybe the hard part for every student, okay, is about potential difference. So when we talk about potential difference, okay, is often very confusing. Okay, you see this word voltage, okay, it is the same meaning as potential difference, right? But even when you look at these two words, okay, they don't really help you, right? So you have to think about this way, right? That in a circuit, okay, when current flows, that means basically the electrons are flowing. So something must cause the current to flow, right? The electrons to flow. So what is the thing that causes it to flow is this thing called potential difference. So when there is a potential difference, right? When there's a potential difference, current will flow. Okay? Okay, so you might still be wondering, I don't really understand. Okay, what it means is this. Okay, let's say, okay, let me change color to black. Okay, so like this, if I have a circuit like this, okay, which connected to a light bulb, okay, here the battery, okay, supplies a potential difference, right? On the left side is positive, the right side is negative. So you can see on the left side, positive, right side negative, there is a potential difference. And then current flows from a high to low potential difference. Okay, that's your conventional flow of current. The actual fact is that the electrons are going from what we call a low to high potential. So you see here is negative, is low potential, here is high potential. Electrons are going in this way actually. But in conventional flow of current, we will say that the current goes from high to low, right? So when you label the current flow, you label it in this anti-clockwise manner. So every one of you knows, right, that if I have a circuit set up like this, right, this light bulb, okay, will light up, no problem, okay, because here is positive, negative. But if I make a mistake and I connect my, let's say a torchlight battery, I put it the wrong way around, I have here is positive, positive, you know that the current will not flow. Okay, but now you know the reason. Why? Because there is what we say, there is no potential difference. You see here is plus and here is plus, that means high potential, current cannot flow when there is no potential difference. So likewise, if I make another mistake, I put my batteries this way, all right, there is no potential difference. Why? Because on the left side and the right side, you see this low potential, again there is no potential difference. So in either of this case, okay, current cannot flow. Why? Because there is no potential difference, right? And first thing, remember that current flows when there is a potential difference. And who supplies this potential difference? The battery, right? That's why you want to have current, you definitely need a battery, right? There's no battery to supply potential difference. All the electrons are there, but they can't move, okay, without the potential difference set up by the battery, okay? So in order to measure potential difference, we use what we call a voltmeter. So when we connect a voltmeter, we connect it parallel, okay, like this. And if you connect over the battery, we can say it's measuring the voltage of the battery, the potential difference of the battery, or the EMF, which is known as a electromotive force. So electromotive force is also to do with voltage, right? It has the same units. All these have the same units. Their units is volts, right? So EMF stands for electromotive force. And this term is only associated with the sources, right? So we are talking about battery cells, the sources. We say the EMF of the battery is what? 5 volts, example, 10 volts. Okay, we cannot say, oh, what's the EMF of the light bulb or the resistor? In this case, over here we will say, use the correct term, what is the voltage of this battery? What is the potential difference of battery? So EMF has to do with the sources, right? But they all share the same units, which is volts. Okay, so I hope you understand a bit more on voltage and potential difference. So let's look at a circuit and see how the voltages are related in a series circuit. Right? So if you see something is a series circuit, right, how are the voltages related? So in this case, in a series circuit, V, the battery, okay, or the total voltage is simply equals to V1 plus V2 plus V3, right? So these are all series to each other. So I add them all up, they should get me the battery V, right? Okay, so if I were to say, if I were to put a voltmeter here, right, V4, right? So what's the relationship between V4 and the rest? Okay, so what you do is you look what is it across. So you notice V4 is across V1 and V2, right? So V4 starts from here, it ends up here, it's across V1 plus V2. So the relationship, pause for a while, you will tell me V4 is equals to V1 plus V2, all right? Okay, so likewise, if I were to say, oh no, I connect another voltmeter here, okay, which is say V5, then you can safely say V5 is equals to V2 plus V3. Why? Because it's across both V2 and V3. So you look at what is it across, okay? So likewise, okay, I make the circuit even more confusing. You look over here, V6, right across here, V6, then you can say, oh, V6 is simply equals to V. Why? Because it's across V, or you can say V6 is also across V1 plus V2 plus V3, all right? So look for the relationship. It's not always so simple to see, but hopefully over time you will get it. Okay, so I've been talking about voltages and potential difference. Remember, these two terms are interchangeable. So let's look at a parallel circuit. Okay, once more, let's say we talk just first about current, right? So you look at the way the current flows. So current comes here, I, it comes to here. What happens? You will say the current splits up, I1, I2 plus I3. Then when it comes back here, it rejoins back to be I, right? So here's I1. After going through the resistor, it is still I1. It doesn't become less, right? So in a way, current is quite easy to figure out. Okay, less so is voltage or potential difference. Okay, so I want you to take note of the certain things I say. Right? When I use this term called potential, and potential difference. Okay, watch out. Okay, so if let's say I were to say this battery has a potential difference of voltage of 10 volts, you can take it to mean that the potential here is 10 and the potential here is 0. So you notice I use the word potential. So, and this 10 potential will keep on remaining 10. Up to here is 10. It comes to here is still 10. Okay, now here is a point where a lot of people say, oh, the potential will be split up into 3 parts. Not correct. Okay, the thing to remember is this: potential only changes when there is a resistor, okay, or something which has a resistance. When it comes across something which has resistance, okay. So here is 10, yes. Here is 10, here is 10, correct. So over here it will still be 10, here will be 10, here will be 10. Reason being, although there are 3 wires, you might think it's split up into 3 parts, but no, because there is no resistor between this point here and these 3 points here. So the potential remains as 10, 10, and 10. Likewise, with the same idea, if I say here was 0, the potential up to this point is 0, and here will be 0, 0, and 0, because there's no resistance along the way. Now what if I say, oh, I forgot, I put one, okay, let me change the color so it looks better. Okay, so let's say I put a ammeter over here, right? So does it affect the potential? Here is 10. Will this still be 10? Yes. Why? Because ammeter has very, 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 very low resistance, negligible resistance. Okay, so it doesn't affect the potential. So what does the voltmeter do? The voltmeter measures potential difference. So if I have V1, it measures potential difference. Over this side, potential here is 10, this side is 0, so voltmeter V1 measures potential difference of voltage. 10 minus 0 is 10. Likewise, here is also 10, here is also 10. So you see in a parallel circuit, it looks quite strange, but true, that the voltage of a battery, okay, if this was a voltage of a battery, it will be equal to V1 equals to V2 equals to V3, right? Because they are strictly parallel each other, so the voltage is same throughout. All right, so if you were to look back into the over at this circuit, so likewise this V equals to V1 equals to V2 equals to V3, right? Because of like what I just explained, the potential from here, this point over here has not changed to this point, this point, this point. All of them have the same potential. Likewise, this side has the same potential as here, here, and here, because there's no resistor. So that means the potential difference measured by voltmeter V3, V2, V1 are all the same. Okay? So a bit hard to understand. Okay, you will get better as you go along. So you have to develop this sense of logic as to see what is parallel to what and what is series to what. So a typical simple example might be this. Okay, so if I have 3 resistors over here, right, and I were to ask you, okay, this is the voltage of battery. Okay, let's say we just simply look at the current first, which is easier. Okay, you will see the current coming from here. This is I total, or current from the battery. Comes to here, what happens? I total will split into I1, I2. Likewise, going through is I1, I2. Then coming to here, they rejoin back. So this is back to I total, and then this is back to I total. Okay, so current, okay, quite logical, can understand. Okay, now how about the voltage? How is the voltage related? So if let's say I were to connect voltmeters across the battery, right, and I call it V battery, okay, or V total, then this one is V1, and then this one is V2, and then this is V3. Okay, so look for yourself and see, okay, what is parallel to what. I hope you can see it, that V1 is equals to V2. They are parallel each other. Why? Because the potential here and the potential here are exactly the same, right? They may be split into two wires, but between this point and this point there's no resistance. So this potential at this point and this point is the same. Likewise, this point and this point is the same potential. So the difference is the same for V1 and V2. So you can simply say V1 is equals to V2. Okay? Right. So do you think this is true? V battery is equals to V1 plus V2 plus V3? Well, the answer is no. Why not? Because this is not a series circuit. If it's a series circuit, this would be correct. So then what is a correct relationship? The correct relationship is that V battery is equals to V1 plus V battery. So a lot of people will say, hey, what happened to V2 then? Okay, how do you see it is this way? Watch. Look, so you see, this circuit is, yes, no doubt a bit series and a bit parallel. Okay, parallel, you can see that these two are parallel to each other. Okay, then what is the series? Okay, the series aspect is this. Okay, look, that this chunk of resistors over here is in series with this R3. So imagine this one is one big resistor. You combine the two of them together, they are in series with R3. Okay, so that means to say that this green square I drew here, number 1, is series to number 2. So if they are series to each other, that means to say that the voltage of battery V1, which is the voltage across this point, very messy diagram, plus voltage of V3 is equals to voltage of battery. Okay, so that's how they are related.